Conic sections, sheet 13. F is the focus of an ellipse and P and Q. F is the focus of an ellipse. P and Q are points on the curve. The eccentricity is 0.75, so ECC equals 0.75. Draw a portion of the curve and then draw a tangent to the curve which will be parallel to the line FP. Just like in some of the previous questions there, draw a portion of the curve. Well, first of all, we need a directrix, an axis, a vertex, and so on. To find the directrix is the first job. Eccentricity is 0.75, which means the ratio of the distance from point to focus divided by points to directrix is 3/4. So right now we have a point and a focus, which is 3 units. And from that point, the directrix is 4 units away. We have a point and a focus, which is 3 units, and from that same point, it's 4 units to the directrix. So let's go ahead and show that graphically. If I divide up the distance from the point to the focus into 3 equal spaces, and I'm going to simultaneously just do the same thing up here. I'll set my compass to whatever measurement I like down here, and I want 3 equal units there. 1, 2, and 3. I'm going to do the same up top. I'll just set it a bit bigger this time. 1, 2, and 3. I'll get my sliding set squares. Joined to the last point. And all I'm going to do is take 1 extra. I'll do the same up top. So I'm just running these two simultaneously now. And just start going this way from here to get 1. Now, maybe if it makes it a bit more clear, my distance from the focus to the point is 3 units and I want to extend it. And my distance from the focus to the point up here is 3 units and I want to extend it. And if I work on the lower half only for now, that is right there. That is 1 unit. I'm going to go ahead and add it onto the line. So now I have my original 1, 2, 3 units and I have 1 more added. The 4 units looks like that. Just open it carefully to the perfect size. That's what 4 units looks like. From P, there's 4 units. I'll do the same up top. Here's 1 unit of the top line. Added on to the already existing 3 units of the top line, which gives me a total of 4 units. 4 units from point Q is there. I'm going to take my set square and lay it up and just make sure it's touching tangential to both curves, which it looks pretty good there now. And the final step here before we can actually start drawing the object is we'll slide back a little bit. That move. Yeah, it did. It moved a little. So parallel to the directrix. Slide away and then go perpendicular to the directrix. Oh, I'll draw about that line now in just a moment. There's my axis. So the axis line dropped in perpendicular to the directrix. I'm going to pause the video. I'm going to rub out that little bit of a slip that I had there, and I'm going to go ahead and draw a lot of the ellipse using the same methods as we've already learned. Our rise over run is 3/4, so I'll set up my line of eccentricity, my vertex, and so on, and then we'll have a quick look at drawing a tangent to the curve which will be parallel to the line FP, which is this line right here. We'll have a look at that in just a minute. So to resume this video, we need to go ahead and draw a portion of the curve is done. We need to draw a tangent. Before I do, just in terms of drawing the portion of the curve there, what I did was, well, I rubbed off that little mistaken axis first of all. I found my rise over run, my line of eccentricity, so I went along, in this case, 4 units of 30, I think it was 120. I went up 3 units of 30, which was 90, drew my line of eccentricity. My green latus rectum perpendicular to the axis was next. I went up with 45 and back down to find the vertex, the usual. I picked up 1, 2, 3, 4 positions there along the main axis and drew some ordinates up to hit the lattice. I went across to hit, or up to hit the line of eccentricity, across to hit the lattice, and rotated back down onto the ordinate for the correct point on the curve. Now finally, draw a tangent to the curve which shall be parallel to the line FP. I went through this in another video. It was for a different curve, but it was quite a similar method for this. I'm going to draw a chord first of all, parallel to the line FP. I'm going to draw a chord, let's just say there. There's a chord parallel to the line FP. The next thing I need in my ellipse is I need the center point. So I need to go ahead and actually find the center of my ellipse now. To do that, I'm going to just bring back in my adjustable set there for the axis. I need to find maybe my second vertex. So from the focal point of 45 degrees. And I just have to extend down my line of eccentricity just that little bit. And that gives me that point. I'll bring that down in parallel to the directrix or perpendicular to the axis. And that's my second vertex right there. I'm going to bisect the distance between the two vertices. So the usual, open the compass to more than halfway. Because I have my adjustable already set with the angle parallel and perpendicular to the axis, I know that that right there is the center of my ellipse. From here, that's just something that had to be found for the rest of the question. I had drawn a chord parallel to the line FP. I'm going to bisect that chord next. So I'm going to open this compass really big now because I don't want this to get mixed up in the middle of all this other construction. So I'm going to go way more than the total into the line. In fact, I'll swing a curve right and left, and same this time, right and left from my bisector. I'm going to join those intersection points of arcs, and all of that work establishes this point right here, the center of the chord. I'm going to expand that point from the center through and out. And the whole idea of that is that no matter what chord I draw along this ellipse, the center point of the chord will be on the line I just drew right now, because it's expanding out. The chord just keeps getting smaller and smaller. The center still lays on the center line right there. So I'm going to go for the final step, parallel to the line FP, which is parallel to the chord in red that I drew, and I'm going to draw my tangent right now. I'll drop that in there in blue. So that blue line right now is a tangent parallel to the line FP, and it was established by finding a chord parallel to the line, bisecting that chord and expanding through the center out to find a POC. That's the end of this drawing. I hope this video was helpful, and thanks for watching.